This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and now the news should actually come. But Peter and I had some technical problems and so we postpone the news until next week and we start immediately with our guest Tom Hammerbacher from MNX Contact. We apologize, there will be news next week. We promise that. Enjoy listening. Hello, Tom. It's good to have you with us.
Thank you, Robert. Thanks for inviting me.
And you're welcome. Before we start into the topic, why don't you briefly introduce yourself to the audience?
Yeah, for sure. So my name is Tom Hammerbacher. I worked for MNX Contact as a solution engineer with focus on data science and machine learning. So everything that is related to data analysis, in my perspective, in the domain of factory automation.
So you are customer focused, correct?
Yeah. In my domain, I mainly focus on customer solutions.
Let's start with MNX Contact strategy for AI. Do you develop it yourself or buy it to implement it at your own plant and later at the customer's plant? What is the AI strategy of MNX Contact?
So MNX Contact, even if many people will not think of MNX Contact as an AI developer, develop their own machine learning models and also develop the needed infrastructure and processes in the domain of automation. So, of course, we use AI in our own production environment, but we want to use it in customer solutions as well. And now we have a strong exchange between internal or customer-driven development and projects to find out which AI models or which MI deployment strategies fits best for customer solutions.
In my opinion, I think you can test the models in your factory.
Yeah, because we create goods ourselves, we know the whole development process, and I think we can clearly see where it's most beneficial to integrate AI in the production process and interact with the production staff or with the process control. That's one huge benefit, that we have a real world test bench in our own production.
I think most listeners associate MNX Contact with connectors, control cabinets, and perhaps controllers. So the AI model is a added product, or is it part of these connectors, control cabinets, and controllers or PLCs?
Yeah, so we try to integrate AI applications in our components, but today we also focus on creating own software portfolios. So in our term, we created a software portfolio called MNX, and it deals with the creation and the deployment of machine learning models. And we make sure that this software portfolio can also be executed, for example, on our PLCs or on our industrial PCs, and later with the integration of an overall operating system on other components of MNX Contact.
The software you mentioned, that will help customers to deploy AI models in their production, right?
Yeah, so MNX is split up into 3 different parts. The first thing is a open source programming library called MNX Framework, and it's for nerds, and it is mainly a software library to kind of get the main and the basic utility functions when you start projects with data science.
Is it an AutoML tool or something? No.
The AutoML stuff is placed in the MNX Creation software tool. So MNX Creation bases on the MNX framework, and it includes AutoML strategies to create the neural networks. And the idea is that you don't need any programming experiences. So you can describe the whole neural network as well as the training strategy in one configuration file, and the AutoML module will interact with the configuration file and try to create a better configuration to create a better model. That's the idea.
Okay, and then you have to deploy it in your production.
Yeah. After that, we use MNX Execution to bring it into production. And that can mean that we can run it on our PLC systems, kind of like out of the box, isolated. We can integrate it on the production servers of the customer's IT. We can integrate it in the cloud. So we rely on container virtualization to really find the best possible solution for the customer when it comes to execution, deployment, but also computational power.
When it comes to deployment, is this the most difficult part for the companies to use AI? Because it's easy to make a proof of concept, maybe to collect some data, then you have a nice model. But I think that's the most difficult step for the industry to deploy this in a real time scenario.
Yeah, I totally agree, Robert. Scalability, bringing scalability to industrial AI applications is a huge challenge. And we see that it is not like you will develop the first AI model and then the second and the third, and you will gain experience. Of course, you will gain experience, but we think of it more as like a fully integrated process into the production. So you can start with, for example, collecting the first week of process data and creating kind of like bad model and iteratively make it better. And this is true for any new domain and any new use case. So of course you learn some principles that work better or worse. But that's why MLNext execution focuses on the independence of the execution of any single neural network, that if something went wrong, you can exchange it without manipulating the other neural networks. And you can do kind of like an A/B testing, for example, so that you deploy multiple models that solve the same use case, and you can see, okay, is it better to use a smaller model, a bigger model, use both and interfere the predictions? That's the overall idea of it.
Do I have to use your PLC, or can I also use the software with a different PLC?
So as long as you can ensure that you either have a Python environment or a Docker environment, you can execute it on other platforms as well. And we created a version of MLNext Execution that is mainly optimized for our PLC Next devices, so our PLC Next control hardware, but we are not limited to it. So you can just download it as fully Docker imageable software.
How difficult is it to translate the AI model to a PLC, to real-time programming in the factory? How difficult is this translation, or to put the software application into the PLC?
Yeah, it used to be a bigger problem regarding the real-time part, but with our new controllers, we have the benefits that we have the real-time part and the non-real-time part. And we kind of like integrated an IIoT device, or kind of like a Raspberry Pi, within the controller. So you can directly exchange variables between the real-time and the non-real-time part securely and without having problems with the computational execution of the real-time part. So it used to be very difficult, but now with PLC Next, it's much easier because you have a full open source, open distributed Linux system on it. And with this, all the benefits of automatic deployment and other libraries and frameworks come with it.
Your PLC is one part in a big production line. If you think about packaging or something, there's a huge line and the PLC is one part. Why should a customer use your AI software and not a different software? Why is it so important that the PLC and the software is connected there?
So that's a great question, because we ask it ourselves in first place. We thought about, why should we, as hardware-driven, product-driven company, would go into domains like machine learning, where we have big players. But we learned that within industrial related use cases, the automation infrastructure plays a very crucial role. And I want to give you an example for that. So imagine that we want to collect the operating temperature of any kind of model. And there are so many options. We could deploy a second sensor, but that could be quite costly. We could duplicate the sensor signals, but we have to be sure that we don't interfere the process. We could communicate with the I/O station or with the PLC itself by having an eye on computational load that comes with the data collection. And each of these steps in gathering the data comes with their own benefits and drawbacks. For example, in terms of data integrity or data availability. And we saw that data-driven approaches mainly follow the principle garbage in, garbage out. So we will not make any kind of real value information out of poorly gathered data. And that's why we think that automation experts also play a crucial role in the data analysis steps, because we know the industrial infrastructure and the industrial processes. So we know how to interfere with PLCs, to interfere with robots, interfere with an MES or an SAP system. And that's why we thought about the whole process to create the best solution possible. Of course, we are willing to work with consulting driven or IT driven companies to bringing more depth, so that we focus on the data collection part, maybe the data storage part, and other do the data evaluation for us.
I thought about the companies who deliver the drives because they have also their own analyze software, their own machine learning software. What about with these companies? Do you integrate these information, these data?
Yeah, so because our PLCs can execute Docker images, we are kind of like very flexible to bring customized IT-driven software to our PLCs if needed. Of course, we have to talk about computational power and the availability for storage. That's why we extend our portfolio from classical PLCs also to edge gateways or edge PCs with more computational power that are not that focused on gathering the data, but more about communicating in the processes or communicating with I/O stations.
Now I have 4 or 5 or 6 production lines. And on each production line, there's a AI model running. Can I get an overview and a software tool where I can see all these models and how they perform? Or I have to go still to production line 1 and look at the PLC? Is there a overview of my models?
Yeah, so the deployment of the models and the visualization tool is separated by an REST API. So you can create one visualization instance and connect to all the different PLCs, or all the different PLCs will gather their data within a certain endpoint and it will filter it to create more kind of like publish and subscription feeling for the data, so you know you're not limited to it. But of course, you can run the whole visualization and the execution of the neural networks together in one software solution.
Let's talk a little bit about your customers, because you mentioned you are the domain expert, and that's a huge advantage for Phoenix Contact. What are your customers' requirements when they call you?
We are domain experts when it comes to automation, but we are often not domain experts in the domain where the customer produces their goods. So we of course need a strong collaboration. For example, when it comes to anomaly detection, that customer tell us which is bad behavior for a certain process or which is okay for a certain process. But we see that it strongly depends on the industry as well as the, I would call it, innovational strengths of the customer. So on the one hand, for example, in machine building, we have a lot of smaller companies that never did a data analysis project before. So we offer consulting for creating the databases and collecting the data, as well as how to analyze the data and how to integrate it into their daily business. And if they want to, they can have a full hosted by Phoenix Contact or a solution hosted by Phoenix Contact that have kind of like a plug and play character. And on the other hand, there are larger companies with strong information technology where the challenge comes more with the integration of the new data analysis use cases in the already used environment and in the worldwide deployment of this solution. What we want to offer for both groups is the customer can communicate his high-level goals. For example, he can tell us, we want to reduce the CO2 footprint, or we want to increase the product quality in a certain area. or the process stability. And we at Phoenix Contact will develop a solution and serve these requirements, maybe on our own, maybe together with smaller partners, maybe together with big partners, and always together with the customer.
Is it a AI consulting by Phoenix Contact?
Yeah. So we noticed that we need the whole process. And it's not only an AI consulting, but also a data collection consulting or a data usage consulting when we say, okay, when we have a neural network and it predicts a certain product quality, for example, how can we directly control the machine to output all the malfunctioning parts, for example?
Let's talk about use cases. You brought some use cases today. Let's delve deeper into them. The first use case you have.
The first use case is about anomaly detection, because our use cases and what customers are mainly motivated in doing, at least in our perspective, are two things: productivity and sustainability. And to our advantage within anomaly detection, we have an intersection of both topics. And that's why we can focus on a common basis for the data collection to, for example, make sure that multiple use cases can be realized with the same databases. So gathering the electronic or the energy consumption of the machine can help us to detect anomalies within the production process, within the machine conditions. Maybe there's a problem with the power consumption itself, and we can use the same data to find out if a machine could operate more energy efficient by interfering the production output with the energy signal.
Mhm. Okay, so it's one model for two use cases.
It is one process, but I think it can be one model, but it's also a possibility that there are 4 different models. So we first start collecting the data with a so-called data collection box from Phoenix Contact. It comes with an energy monitoring device as well as with exchangeable modular interface modules to collect digital or analog signals. And the box includes a CEE plug as well as a CE socket, so to easily integrate it into the power supply of the machine. And then we can collect, for example, the process step of the machine by duplicating sensor signals or by communicating directly with the machine's PLC. And with the help of the information, we create deep learning processes. And these deep learning processes can result in one or multiple models. For example, to detect anomalies within the production process. So in our case, we mainly focus on using 2 different model flavors: variational autoencoders and default neural networks. And we combine the information to train a model in an unsupervised as well as a supervised manner.
How do you do that?
The autoencoder is trained to reconstruct flawless production data, so in an unsupervised manner, and a drift between the reconstructed and the real measured process values identify anomalous behavior. That's the one part. And then we have the default neural network that is trained supervised on labels that are created based on the quality control later on in the process, or based on maintenance steps. When they know that the machine operator see, okay, we have a problem here, he can label the process data, and then we interfere the results from the autoencoder, and we even interfere the training. So the encoder part of the autoencoder shares some neural network weight with the vanilla neural network. And therefore, the overall model is forced to, on the one hand, learn this reconstruction part, and on the other hand, focus on predicting the correct labels.
And do you use this model or this trained model not for only one customer? You can sell this to other customers too.
Yeah, that's a part where we definitely have to learn more about the behavior of our models. So in theory, if we have trained this anomaly detection mechanism for a soldering machine, it should work identical or kind of like similar for another similar soldering machine. So we try to work with techniques like few shot learning, where we take the neural network and we only want to improve the model itself. But we have domains where it worked kind of like perfectly, and we have domains where it didn't work at all. So that's why we now focus on finding automated ways to do the all ML operations process, such that if you fail, for example, with a few shot learning, we can start to create a new model from scratch more easily and automated.
Do you use a Hopfield network to do the few-shot learning?
No, we just use the vanilla neural network procedure and kind of like retrain it or further train it. And in our perspective, what was really kind of like surprising, because it was quite simple, is to use new information and repeat old information. So we deliver the model as well as some default old values, and we just switch between learning from new values and revisiting the old data for the model.
For our listeners, we have a very interesting episode with Professor Sepp Hochreiter about future learning and Hopfield networks. You will find it in our podcast episode, I think in 100 something. You have to look up. It's very interesting, this future learning. Why you use this future learning? Who had this idea?
The idea is kind of like motivated from other domains like natural language processing or image processing, where pre-trained neural network kind of like fits very well. And we thought, why should that not be true for time series analysis? Because we thought about that machines, when they are similar, they kind of like have the similar process steps, and there should be kind of like some data interference, and we should find some benefits within this process.
Do you have one more use case?
What we plan to do is to predict energy saving potentials, within workstations or work groups. So the idea is that we collect the energy data from multiple machines, and in the best condition, we also get the information about the output, and we can create neural network that is trained to kind of like predict the perfect production output based on the energy consumption, and then we can compare real values with predicted values to spot differences. But for example, for manual working stations, it's quite hard to automatically detect the production status. So what we did is to create another neural network, kind of like a smart sensor neural network, that uses the energy data to predict the production step in which we are in. And then we use this information to as label for another neural network. That's something where we don't have the full process set up yet, and even haven't the whole automated process, but we see that we can find a lot of information about process behavior and about machine behavior within the energy footprint. And we believe that it could be more beneficial to have a common basis in collecting energy data and bringing a neural network to derive the information we want to, except in adding additional sensor, which comes with hardware costs and integration costs.
You talk a lot about neural network. What about statistic and mathematic methods? Are they still there, or do you combine them?
Yeah, of course we use statistical approaches. So, and we even have, I think, less enhanced methods. So we see that if we just visualize the data, visualize the process data, the energy data, domain experts can spot, for example, anomalies, or can spot misleading operational points of the machine by just looking at it without any kind of domain. So just the visualization of the data can bring a benefit. And then we create moving averages, for example, of the data, and visualize them, or we interfere, or I think it's another visualization thing. We visualize the variance or the standard deviation, and we also include the statistical approaches in the neural networks. So for example, for our variational autoencoder, instead of just using, for example, the A2 norm as a difference measure for the reconstruction, we use a likelihood measure and calculate the likelihood of the input data belonging to a probability distribution that is created at the output of our model to improve it.
When you come to your customer, because when we talk to other companies, to machine building companies, to automation companies, they all report that the customer do not believe these neural networks or these outcomes or the numbers that are coming out. And how difficult is it to explain the customer to trust this technology?
That's definitely another problem, I would call it. So in first place, it's that we just make recommendations and we just visualize the data without any kind of like alarming system or something like that. It's just that the production staff, for example, or the maintenance team can kind of like look at the data and look at the predictions. And then it's kind of like a step-by-step integration. Maybe one maintenance guy says, okay, it's cool that I see the data, but I want to have precise alarms when there's a failure. And then we integrate the alarm system, or maybe we just enable it because we have it with us. And after it, he says, okay, I want to have the alarm as well as some maintenance suggestions, for example. So the maintenance team can create kind of like a digital maintenance book where they can write down what happened at the machine and which maintenance operation helped to fix the error. And then we can show them their interpretation of the error once we detect, okay, this error kind of like looks the error we had before, and for that we have a maintenance suggestion by the team. And it's a process that takes time on the one hand, and that you can't really force. So we have a project in our own production where we have a machine operator that don't trust the anomalies. So the anomaly occurred and the machine operator says, nah, that's okay. Another one and another one. And it came to an anomaly, but he says, okay, that wasn't a big deal. But then we have a false positive. And the machine learning model indicates that there isn't an error and there was an error. And that was a point for the machine operator to accept what the model will output, because he understands that the model itself, it's just kind of like a tool for him, a statistical tool or a heuristic that helps him to decide what to do, but it will not force him what to do. And then we have other domains where we, for example, have injection molding, where we can kind of like connect the things that the machine operator do and the things that the neural network outputs by an and or an or. So any kind of like logical interference of the predictions to output bad quality, for example. If we detect that the process stability was not perfect for the production step, and then we just output the products that are produced. And for that applications, most machine operators really don't care about it.
That's very, very interesting, Tom. But at the end, I have one more question. Let's look a little bit into the future. We are talking about reinforcement learning. What are the techniques for machine learning you see in the next coming 5 to 10 years with Phoenix Contact?
The things that we want to find out with reinforcement learning is if we could create an anomaly detection system, for example, for robots or for any kind of machines that can find anomalies better than we do. Because when we train them in a supervised manner, it always comes down to what the production steps will label. And with this more like reinforcement learning, we can try to automate this process too. And if we look at robotics or the navigation of vehicles within the production, that's some parts where we want to explore reinforcement learning and maybe interact reinforcement learning with evolutionary algorithms to kind of like speed up the reinforcement learning process.
It sounds very, very interesting. And we wish you all the best for your testing and for your product. Thanks a lot, Tom. It was a pleasure to have you here in the podcast.
Thank you so much, Robert.